Nice. Okay. So we're gonna discuss issue 4119, where jobs are being marked as successful for Kubernetes. Georgie, do you want to take over?
Yeah, sure. So basically that's the issue. We have it here in the agenda. Basically, when we execute commands inside pods, we wait for the walks of the commands and for the exit status of the commands. And let's say if we execute a command which takes a minute to run, even a simple sleep, if in this 60 seconds while the command is running, if let's say there are some connectivity issues in the Kubernetes cluster or in the networking stack in general, the connection between the runner and the Kubernetes pods can be broken. And once the connection is broken, we get no error back. We get a new error, and that's when we assume everything is fine. And at this point, we just continue the process, which means we mark the job as successful in GitHub, and we cut off the walks at this point.
So basically, to make sure I understand correctly, when like the connection dies, so the stream dies, and we don't get an error when the stream dies, basically, right? So that's why we mark it as successful.
Yeah, and it's a specific case. Like the networking stack has no idea the connection is killed.
Okay.
The networking stack just tries to read some bytes from a stream, and it gets back an enter file, and 0 byte thread, of course. And this is a case which isn't handled. I can just show you real quick where this is. Like let me see. No, it's not copy. So basically, this is why is everything so slow? This is the place in remote commands where the basically the connection is handled. So this is the place where stdin and stdout are basically being copied to the walks. And there's a special error stream, which is part of I guess, of the Kubernetes communication protocol. And this error stream can decode a message. So it expects some kind of message, which is this kind of message. And usually it's going to get a JSON and it's going to get decoded. And we're going to get whether the command was successful or failure. And in this case, when this error stream method is trying to monitor the stream, IOQ returns new instead of error. That's basically because the bytes package handles enter file, and when it sees enter file, returns new. That's basically how the ghost bytes package is implemented. So we basically get no error, we get no message, and we default to this case, which returns new.
Okay.
And this is actually like the root of the problem. And it's kind of specific because there might be a case where the connection legit doesn't have anything to send back to us. But we still get enter file. We don't get enter file. The connection gracefully closes. For example, from our end. And this isn't like a guarantee that there was an error in the message, but we're going to get to that a bit later. I'm going to get back to the agenda.
Okay.
Yeah. So this is the root. I'm just going to go real quick to how we use this. This is we execute multiple commands in the pods, and we wait for each command to execute. We execute them in a certain order. And that's why we run this exec and we wait for the result back to get back. This usually isn't new. And we have this exec file. This is the last place in our code before we actually execute the remote command and the code I showed you before.
Okay.
So the problem is here. A remote command attaches. Basically, remote command creates an HTTP2 connection, and to this HTTP2 connection, we create multiple streams for standard input, standard output, and the special error stream, which is part of the protocol. And basically, if we kill the HTTP2 connection, we get enter file, and so it happens the thing I explained.
Okay.
Let me know if there's anything unclear yet.
No, I think that's pretty clear. So, like, if I understand correctly, basically we have an IO util read-all. It's not returning an error, so we're not realizing that it failed. And like the job failed because of some odd reason, and we're still marking it successfully because we didn't get any error exit code from the stream. Does that make sense?
Yeah, that's exactly it.
Do you like? I'm not 100% like caught up on the Kubernetes executor. I haven't looked at it in a while, but do we only look at the stream output when we define the status of the job, or do we look at other stuff in certain other scenarios?
No, we just look at this error here.
Okay.
That's it. If there's an error, it failed. If there's not, it didn't.
Would it make sense to, like, for example, check something else? Like, can we check like the pod exit code or the pod events or something like that? So we have like two ways to check if a job can fail or not. Would that make sense? Instead of relying on the stream?
We can't check the exit code of the pod because the pod is going to be still running. We are running an additional command inside.
Fair enough. Yeah, good point.
Yeah, so that doesn't work. We could theoretically check for the status of the process. Like we can run PS inside the pod from another remote command. That's a possible solution, but it wouldn't be my first choice.
Okay.
We could add it here.
Yeah, I'm gonna add it here. And your other solution is, so we modify the remote command so we try to reattach the stream.
Are you reading part 2? Like point 2? Yeah. That's one. So this point consists of two possible solutions. We need to modify a remote command in this case if we want to try this. What this can give us are two possible outcomes. We could either be allowed to reattach the streams. Let's say, I don't know, I haven't tried it so deeply. Maybe the HTTP2 connection is gonna reconnect. We're basically using Go's HTTP2 stack. So we create streams on top of the HTTP2 connection. So if the connection dies, it could reconnect. If it reconnects, we could recreate the streams on top of it, passively, and we could just resume listening to standard output of the process.
If we reconnect with the stream, would that re-execute the command we passed it in the first time, or would that just reread the buffer basically?
Yeah, we read the buffer if there's a buffer, if that's how it works.
Okay.
We are not going to re-execute the command because obviously that can bring some side effects.
Yeah, and how would we know if we need to reread these, like reattach the stream, since we don't know that the stream dropped off?
Yeah, that's a good question. We could, let me just find it. We could check if we have already gotten like a status response. If we don't have a status response yet, that probably means the connection died unexpectedly.
Okay.
That's one possible way. Another possible way is don't rely on IOUT-RETO. We could implement the buffer reading ourselves maybe. Or we could just handle the case where we get no error and no message, and then we could just retry. It's not going to be like expensive or it's going to be wrong.
No, okay. Yeah, fair enough. We can always just recheck it if there's no error.
And yeah, that's in the case where we can actually reconnect. And if we can't reconnect, we can fall back to checking if we have the status response, and if we don't, we can just return an error and saying the connection died unexpectedly. So we're at least going to solve this problem where the job is marked as successful, but it's actually not.
Can you repeat that? Sorry, I did not understand.
So let's say we cannot reattach the streams again.
Okay.
And we get to this point, and we get to this case. We could check whether we have already received some status response, and we could, at this point, we could say we haven't received the status response. This probably shouldn't happen. So you get an error. I'm not 100% certain how this protocol works. I couldn't find any docs, so it's gonna have to be tested.
Yeah. Okay. The reason I do not like mucking around with the stream, because it's still the network, right? It still can go wrong in multiple directions. If the stream disconnects, does the process still execute? So let's say we pass in the bash script, right? That needs to be executed. And the stream disconnects midway. Is the bash script still running in this case?
Yeah, I tried that with kubectl exec. And kubectl, when you gracefully quit kubectl exec, it stops the process. I'm not sure if it stops when the connection dies randomly.
Because one horrible idea that comes to mind right now is update the bash script, so if there's an error, it puts a file somewhere and we read that file to get the status of the pod. So we don't rely on the stream at all. But if that would not be the case, if the stream dies and the bash script stops executing, that wouldn't work at all. Would that make sense though?
Yeah.
Like, what are your thoughts?
Yeah, that makes perfect sense, by the way, because we can just we could run the process in the background. It doesn't need to be attached to this wonk running exec we have here.
Yeah, because to me it feels like, yes, the stream is the problem, but we might be using the stream incorrectly. If that makes sense, like it's so flaky that we cannot rely on it, because yes, we have a problem right now, but in the future it might show up as a different problem and we won't be able to check it until we actually test it out manually.
Yeah, we could just do basically something like this, and we can run two commands. That's just thinking out loud. We could read from the file. stream from the file, and we could also check if the process is alive using PS.
Yeah, so yeah, that's good. So what we have for example, the shell executor for Bash, we redirect to standard output, right? But for PowerShell and Batch, we save the file and then execute the file. So we can do something similar. Instead of streaming to the standard out, we send the files. If there's a way to send files to Kubernetes, and we execute the files, and then we can read from the stream. I'm not sure if that makes sense, if that's a big change. I have not. I'm just thinking out loud here.
It shouldn't be such a big change. I don't think so. We can wrap this command in, yeah, whatever, and we still have the input, and we're just not gonna have an output and error streams. Theoretically, this is not gonna be such a big change, and then we have to check the file and the process status, like periodically, like a few seconds.
Do you have any thoughts, Tomas?
Well, my first thought is that I joined a discussion and first thing I hear is, let's just get this part of Kubernetes inside of our code base, and and immediately my red light above starts blinking, like we are doing something terrible wrong. And like first thing is that I don't think now about this file redirection and problems with reading streams, because reading streams is one of the basic things of kubectl exec, and I don't think we are the only user on the world that relies on this. If Kubernetes for some reason will start have problems with attaching to the pods and reading the streams of any command that is executed, it will need to be fixed quickly. Now we are fighting with some really edge case scenario, and in most cases this just works. So we need to find a way to basically, the biggest problem is that not that there's something wrong is happening. The biggest problem is that we don't detect that this is happening, and we say everything went okay. Of course, there was at least one client in the issue that claims that he sees this every time or on every build, and in his case, it would be just that he would get all of the jobs failed. But I think this is a second thing that we should look on. The first one is how to detect the problems. I really don't like the idea of getting the remote command implementation inside of the runner. Making this up to date with Kubernetes will be a help. Second thing is that, okay, we will try to reproduce this, we'll try to reattach to this, how this works on the Kubernetes side. Because copying the client library stack and changing it so that we can try to reattach, it's easy. The question is the Kubernetes server supporting this? And how to find what to attach to. Like, I've never seen how to attach to a running exec command. You can attach multiple times to the main command started from the container, but the exec was always independent one-time entity. Like, you start exec, you can see it ends. And I'm not even sure if Kubernetes will allow us to reattach to this. So this for the problems that I see. Have we thought if we can move out of exec and start using attaching to the container? Because I don't remember now which executor it was. At some moment we had two different implementations, like Docker or Kubernetes. One of them was starting the container with the shell detection script in the as the main command, and then was executing all of the runner scripts through the exec. And the second executor was attaching to the running container and executing the scripts. And at some moment we changed one of the executors to just make them working the same, and we chosen to use the exec one.
Yeah, so that was my change actually. So the way the current state it is right now, the Docker executor basically sets the P1 of the container, the script we give it, right? So it's like the shell detection or the build script whatsoever. So we can get the exit code from the container status. And that's how the Docker executor works. But for the Kubernetes executor, we start the pod and run Kubernetes exec with the scripts as standard out. And the reason we had it like that, I'm not sure the reasoning, that was before I joined, but the reason we wanted to change Docker to work the same as Kubernetes, meaning having the containers stood up and then run Docker exec, is for the Windows, the interactive web terminal for keeping the environment when the job has finished. So the current behavior is if you have the interactive web terminal open and the job is finished, there's a configured timeout where it will wait for example, 30 minutes until it stops the pod, right? So if the job is finished and you're connected to the interactive web terminal, you can still like look around and like change files and things like that. So that's why we wanted to change the Docker executor to be the same as Kubernetes to use kubectl exec. That was the idea behind it, and that's why we kept using kube exec for Kubernetes, because we depend on that feature for the interactive web terminals. Because if you look at in the link, the questions one, I sent a link that was from someone community contributor who rewrote the Kubernetes executor by using jobs, but it's using jobs in a different way. It's using jobs as it's being done with the Docker executor. The script is what the job is executing, so he can look at the exit code very, very easily.
Yeah, it basically runs a few scripts. You have one main script, and everything is run inside, and you just touch with walks.
Yeah.
But this, by the way, is not related to jobs.
No, not this one. I in the bottom of the agenda under questions, I sent that link. That's an implementation of the Kubernetes executor from that one. The questions, not that one, but the merge request. I'll send it on Zoom chat to make it more clear. That one.
Yeah, I just want to see if this is the same one. No, it's not the same one.
No, okay. This is a whole new project. It's not a merge request.
Yeah, I've seen it, I think.
Basically, it's just creating a job, and it's doing what the Docker executor is doing. So it's not relying on kubeexec or anything like the job. The script of the job is the script GitLab runner generates, and that it gets the status outside, basically. So go ahead, Tomasz.
Okay, but what if we would like to switch to the attaching to the main process of the container? How this creates a problem for the CI web terminal?
Because the CI web terminal, one of the feature is if you're, let's say, the job is still running and you press the debug button, so you have the web terminal open, right?
Yeah.
And when you have the web terminal open and the job finishes, you can still use the web terminal. You can still use it for like 30 minutes. It depends on the configuration. So that's what it would break. If we change it so like the script executes the attach, like we can't really detect, like we can't really stop it from stopping, keeping the pod alive. Does that make sense? Like, I'm not sure if I'm explaining the problem properly.
Yeah, I think I get the problem. I thinking how we could change the execution of the script to have the output, but doesn't stop the container in case when it fails. Because the biggest problem with exec is that we don't really have a good way to reattach to it and to detect problems. With attaching to the container, we can get back to the same executed command multiple times. And this would just make things much easier if we could attach to the container, not to do the exec. Yeah, but I get the problem of the debug terminal.
I wonder, would it make sense to have the life cycle of the pod like this? So we create the pod, we upload the scripts, and then we execute the scripts like that. Would that be more reliable instead of depending on cube exec and we pass that script as standard out?
Remember that the scripts are being executed by runner in common build, and we have the rules around what script in what case should be executed and which error next is propagated to the job error. So if we would like to do this like that, we would need to upload also the control of script execution there and somehow switch off what runners does. Also, okay, let's say we will even if we would do this one by one, we upload the script, it's in the container, we start it. How we will get the trace, how we will get the final result. This is where the failure happens. Not on starting the execution, but on watching on the execution. We still need to read the output. We still need to look for the exit code, and we still need to make it not failing or falsely succeeding in case of network problems disconnecting us from the output.
Yeah. Like for the, I'm just throwing out ideas at this point. For all your questions, we can always redirect the output, standard output and standard error into two different files and read those files. But reading files will always be a bit messy and writing two files.
Yeah.
Georgi, you started analyzing the Kubernetes internals, and is there a way how, well, my fair question, because this is what you were talking when I joined, do we know in which place the error is happening, where when the network connection is disrupted?
Yeah, we do. Yeah, it's right here. It's if you go a bit deeper, you go into the bytes package, and this is like we read 0 bytes because the connection is dead. We get data file and we get back 0 and nil as an error.
Okay, can you slowly go back through the calling stack? This is
Yeah,
called from
that's from EOUtil reto.
Okay.
Yeah, so we go to buffer, read from, IOUtil reto, and we get back here.
Okay.
So we go to this this statement.
Okay. How we can detect this problem on the router level? Is there any other case when the IO EOF could be returned?
Yeah, it probably could. I mean, even with graceful shutdown of connection, it's probably going to return end of file. But the thing is, the connection can always send back null bytes again. It doesn't need to be there to send null bytes. It just can be inactive.
Need to look into the code. It's vendor 8SIO.
It's client go.
Client go tools. Remote commands. And this is in arrow stream. What's the error stream reader? PD connection.
Are we sure that it does not, if the stream dies, like it does not register an event on the Kubernetes event log, or?
No idea, honestly. In any case, I don't think the event walks of Kubernetes are going to be reliable. For example, if your cluster is under pressure, the walks are going to be deprioritized, so they might come 15 minutes later if they even come.
Fair enough.
Mm.
Mm.
Okay, but we need to solve this somehow, even if all of the calling stack is just not supporting finding this out.
I mean, would it be such a bad idea to do a breaking change on the interactive web terminals?
Sorry?
Would it be such a bad idea to do a breaking change on the interactive web terminals?
Yeah, well, it basically makes it unusable for the moments when you would like to use it.
Yeah.
When the job is succeeding, you mostly don't need to use anything like that. Damn, why this doesn't allow you to detect that the stream was broken? Like, this seems that this should be the basic functionality of a networking communication software.
Should we try and ask
Yeah.
in the Kubernetes Slack channel? Maybe someone can help us with an API machinery sig or something like that.
Yeah, we can ask the question. Maybe someone was fighting with this in the past.
You know, Georgie opened an issue on GitHub, but we got
Yeah,
zero.
I could do it after this call.
Yes.
I think we have enough context now.
Yeah. Yeah, I would imagine SIG API machinery would be the people to talk to since they handle the API.
Because if not making it a variable, then we basically need to check everything by hand. Like, I don't think we need to start with the logs, push them to the file, and then manually stream them from the file. But detecting the final exit code of the command.
Yeah, we already trapped
somewhere.
Yeah, we already trapped the command, right? So we can just save a file, job.status, and read from that.
Yeah, but how do we stream the file?
We don't stream after.
We need to stream it in a reasonable fashion. So if we read 10 lines and the connection dies, we need to resume from the 10th line. It could be possible with some help from some binary on top of it. I don't know, but otherwise,
I don't think we need to stream this. We need to have
just read it, no?
Yeah, like let's consider like that. We update the executed script. Need to think if this should be on the Kubernetes string or for all of the executors. We update the executed string so that the final exit code of the script is saved a file on a known location. The location would have, for example, the project URL, job ID, and the sequence ID of the script execution by the runner. So we have a unique file for this specific file, this specific script that was executed. Now, the command exits, we get a non-zero exit code. This means that for some reason, the command exited with an error. In this case, we don't need to do anything more. We just fail the job and propagate the exit codes as we do now. If we got exit code 0, then it may be that the job finished okay, or it may be in this strange case. For exit code 0, we always execute another command that just reads the file and give us the output. The problem, if there is something really strange happening in network, this may also fail.
Yeah, but this can be retried.
Yeah, we can retry it because we know the bytes we should, the amount of bytes we should read. So if it's less or more, just retry it.
Yeah, we can retry it. We and with a script as long as cat and the name of the file, for example.
Yeah.
We should really have very, very bad luck to fail in such networking problem again in such quick timing. And then getting this output, if we just can parse it and we can set this as the final exit code of the script. If it's still 0, then okay, then it means that the job just finished well and the initial exit code was probably okay. If the file doesn't exist, we probably are in the case that we are looking on now, and we then should repeat it. And this is the next question: how we will know that the job is still being executed? Like, first thing we need to check is if Kubernetes is breaking the script in that case. However, from the issue, it seems that it not, because we get the positive output of the job, and people say that it's still running and it fails in the background. So I would assume that Kubernetes still execute this job, but this needs to be checked. So then we need to have a way to detect if the job is finished and check the exit code file after it is finished. So some sort of run file that is created when the job is started and removed at the end. It makes the final script a little longer because we need to check if the file is created. If yes, wait some time and repeat. If not, try to read the exit code from the file. Seems messy, and such manual checking that would be done for more than half of jobs. Let's assume that most of the jobs are successful. This means that each time we do this stuff only to detect if there were any networking problems. But for now, I just can't find any other solution.
Going with that scenario, if we're writing files, would it be simpler and less harmful if, for example, writing the status of the job of the script on a file, we use the attach method, but when the user connects to the web terminal, we write the file and check for that file? Would that be simpler instead of doing all this logic you explained, for example?
Can you repeat what you want to do? Because I don't think I understand.
Okay, yeah, same. Fair enough. So let's say we're saying we can't use the attach method because we will break the web terminals, right?
Okay.
So the reason we break the web terminals is because the user can't keep using the web terminals when the job is finished. would it make sense, instead of doing the logic that you just explained, every time the user connects with the web terminals, we write a file somewhere, and before we terminate the pod, we check if the file exists or not. If it exists, we keep the pod around or not. Would that even work?
Yeah, remember that if we will use attach, you execute a command on the main process of the container.
Yep.
Now, if this command fails, it fails the container. The container is stopped immediately.
Yeah, but
outside of our control.
Yeah. But in the command, we can check if that file exists or not. No, when something happens, because we trap the error. So in the trap, we can check if the file exists. If the file exists, just do a sleep, for example. Would that be simpler than, like, it's still complex and it's still messy, but would that be less messy than what you explained earlier?
Okay, and then we for example sleep for the amount of time that is configured
exactly.
for the CI web terminal, and after this sleep we exit with the exit code that was trapped, right?
Yeah.
And this then is counted by runner as the exit code of the script.
Yeah, we already do that, as far as I know. If you're connected with the web terminal, you do not update the job status. If the job failed because of your script, we still keep that correct exit code.
Yeah, but
we would have to.
Now this is on the exec, so we just get the exit code returned by the exec right now, and on the runner side, we just wait with stopping the container. Here we would need to do this inside of the script.
Yeah.
And then the problem is that now we can get this exit code. I think we are showing it to the user that this is failed, and then you have still this, let's say, half hour of the terminal working. Here, from user perspective, you look on the job trace, you see that it's not updating, but you have still access to the web terminal. And we have no way to say to this user that this job is already failed and you have your last 30 minutes to check what's happening there. So we would need to find some way to pass this out here without stopping the container. However, the simplest one would be that in the trap script, we could, when we detect that the web terminal is connected, we can just write this in the job output. It will be it will look a little different than how it looks now, because then you would look, then in the job log you would have something like your command, some output from it, and something like your job failed. You have the 30 minutes for your web terminal to use. And when this is finished, you have the normal red failure with the job failed with exit code, blah, 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 blah. So we have this information doubled, but it seems that it would be easier to do something like that. But this requires us to totally rewrite how Kubernetes executor works. So we need to be sure that we want to go this way.
Yeah.
Okay. By the way, if we go back to the solution Tomas provided, um, we can read the output of the command we execute in exec. What if we just add some stupid flag for which we can check whether the process exited successfully? Then we can know whether we should check the status code inside the file.
That might be a good idea, actually. So we don't check it every time the status code is 0. We check it when there's a missing log line, for example, right?
Yeah.
Rather, if there is some specific log line sent.
Or that, yeah. That might be.
It is a solution. I don't like relying on parsing the output, but it would be definitely simpler than what we were talking a moment ago about, and the output of the job from user perspective would be identical like it is now. Because we would not stop the container, but we would still get the information about the fail.
Yeah.
Mm-hmm.
Yeah, and by the way, like in the really long term, we're probably gonna remove this because I guess it's kind of a problem for people where they get their jobs to stop in the middle of their work. So we might want at some point to rework the Kubernetes executor in some of the other ways you guys suggested. Uh, maybe move all the scripts inside. I don't know, something more complex.
I'm not sure I get your last point, Georgie.
Yeah, last thing I said was at some point we might want to find a more complex solution, but that's gonna allow jobs to actually not die in the middle.
Yeah.
But maybe using this solution for now just to solve this issue and allow people to have their jobs displayed properly is going to be enough.
Okay, so can we write down all of the ideas that we have that we think may work? Because we will need to go back to Elliot and Darren and just start thinking about what to do next.
Yeah. So under action points, we have the have runner script save status and file. Should we go into more detail about this?
Yeah, you can add that we can check the output for a marker just so we don't forget.
Check log output.
This was discussed in the context of switching from exec to attach.
Uh,
So we have here two ideas. The first one was that we still use exec, but we save a file on a well-known directory where you can check the exit code, and another where you can check if the script is being run or not.
Okay, now I'm confused. So wasn't this one about keeping kube exec, but saving the status of the job on file?
Yes.
Okay.
This was the one. The second one that we discussed was that we switch from exec to attach. We stop sending the exit code and killing the container. Instead, we look for some specific marker in the output, so we can decide what is the status of the script execution.
Yes, okay.
And then this should support also the web terminal case.
Okay, now I'm confused. I was talking about the previous point.
That's how I understood Georgie as well. The way I understood it, Thomas, is because you said we will check the file status, the job status, the file we save every time the kube exec returns a status 0, right? Just to make sure that the kube exec did not get terminated. But instead of doing that, like instead of every time it's 0, we check it. We do, okay, it's 0. Let's check the job output. If it has this missing job log file line, we will actually check the file status, because we know if the log has missing data, we should check the file because the kube exec got terminated. If the exit code is 0 and we have this log line, we know that the actual kube exec ran successfully, so we don't have to check the file at all. So is that what you were trying to explain, Georgie?
Yeah, same thing.
Okay, so just write down what you think the solutions are, because I still think we are talking about two different things.
Okay, so
and if this will be not what I'm thinking about, I will just add my idea to the list.
that's how I understood it, Georgie. Can you check?
Yeah, That basically it's just we're not gonna know the amount of bytes. We might need to read one line. I guess that's going to
Yeah, yeah. Well, if it's just a 0 or a 1, fair enough, because it can be more than 3.
Yeah.
Yeah, fair enough. All right. You can just do it a pass RFA kind of thing.
Yeah, that's descriptive enough.
Yeah, but in that case, if we are looking on this, using the file has no or maybe yes. Okay. I was thinking about something different. So this probably just should be deleted.
Yeah, I'm gonna delete the first to check PS status. What's it called? And this one is pretty much the last one we explained. Should we ask something in API machinery to see, like, what should we ask if we want to ask them something? Like,
We could ask them how can we detect an abrupt death of the connection. By the way, I anticipate their answer. They're going to say exec is not for long running process.
I'm thinking the same thing, but
Okay, so if exec is not for long running process, can we do the same with using the attach to the main command?
yeah.
If we will remove the sending of exit code, if we rely on some file that is saved to read it, then it should be not a problem for the debug terminal, and we can attach to it again and again and again.
So you would say we asked them for an alternative for kubeexec, or what do you mean?
No, I'm not talking now about what to ask the API machinery about. I'm saying about what in case when someone will tell us that kubectl exec should be just not used for long running jobs.
So let's explain it to them. So let's explain the problem. So the reason we can't use kube attach basically is because we need to keep the pod around even if when P1 is finished, right? because of the web terminal.
I don't know how the web terminal works. I guess the main process of the pod is just sh. Is the main process of the pod just sh?
Yes, it's SSH.
And how does the web terminal attach to the pod?
Just kube exec sh, and then we proxy the std out and std in to GitLab.
Okay.
So it's just another exec we're executing.
Yeah. We basically just need to keep the pod alive for a while. Yeah. Usually, theoretically, we should be able to create a bash script which never dies. Theoretically.
But how would we know? Like, yes, but then if the bash script never dies, we'll never get the status code of the pod, right?
Yeah, we could capture error codes, and the successful code we can easily capture is going to be below at the end. And we can then capture error codes and send them to a file.
Then we're back to the second point, right?
Yeah, and it's going to be maybe that's what Tomas was thinking about. We can read the logs, and we can get to know when to read the exit code of the process. But yeah, that's one way to keep to work with the touch, and we can get the logs with kubectl logs, of course. But we're probably going. Yeah.
Can you write it down? Because I'm not sure I understand you. Sorry.
Yeah, I can write it down. It's just we get back to the other program, but we still need to write it down. So let me get to that. It can be tuned. We can even, like, if the process never dies, it could even send this information to the logs. Like the logs of the pod are never going to be lost. We can read them as many times as we want. So we can use them for information instead of using files. That's just thinking out loud, of course. Might be done.
So, for example, let's say the job success or job failed would be inside of the kube logs.
Yeah.
Yeah, I guess that could work. Where I'm not sure if it's better or worse than.
Yeah, it just.
But even if we get job success and job failed, how would it work? We will check for those logs, and Okay, let's say there's a job success. Now, am I going to check if the user connected to the web terminal? If the user connected to the web terminal, just do nothing. But if the user did not connect to the web terminal, just kill the pod, since it's an infinite script.
I don't know how that works. So
Well, I think that we can just reuse what we have now. Like right now, if the script fails, it fails in the context of exit. The pod is still running. So we still need to kill this pod with this infinite sh process running. And this is exactly the same case. We just don't rely on the exit code. We rely on some specific lines, some specific words in the output that just makes GitLab runner decide, okay, this job succeeded, okay, this job failed. And the logic for the web terminal is already there. How to and when to kill the pod when the web terminal is open.
Yeah, fair enough, because the cleanup happens afterwards.
Yeah, like this doesn't change anything in how we schedule these right now. We just change the way how we detect the exit code of the script.
This might be simpler, actually.
yeah, might be.
And then we could try also to switch, because well, if we want to use kubectl logs, we need to switch from exec to attach. We need to start executing everything on this main process.
Yeah, but maybe I'm missing something, but I don't think this is going to be simple because someone still needs to orchestrate the whole order of the process.
Fair point. Because it has to be the whole stages of the job.
Yeah, but like this doesn't change the stages. We still get the information about the script failing or succeeding. And at the level of common build where the job stages are executed, we even don't look on the exit code. We look on the error that was returned by script execution or not. This is what the executor is responsible for. So in case of Kubernetes, we can just push all of the logs through some loop that will read it, check if there is the marker that we want, and push it further. If we will detect this marker, we remove this line from the output, so it's not printed in the job log page. But we just know that the command was finished or that the command was failed, and we just do the same that we now do when we detect that the process exited with a failure.
Yeah. We just have to basically have all the stages and the attach all in one go.
Yeah.
And would that work for artifact upload on success and artifact upload on failure?
Why you say we need to have them all connected? We don't.
No, never mind. Yeah, you're right. We only have to have.
We can attach multiple times. Each time, well, we from common build we run execute the script. This uses the executor to somehow schedule the script on the target environment. In case of Kubernetes, in this moment, we attach to the running container, send the script through the SDT.io.
Yeah.
And then we attach to the logs and we start reading from them. We read from them until something breaks, like again, the networking stuff, and then we can retry it. or we get the marker that says that the job succeeded, and then we return from this command in the exact same way how we do it now, returning it without error. Or we get a line that says that we have some error in the script, that it internally would exit with the exit code something, but we just make it not send the exit code. And then we know that from the Kubernetes error, we need to return the error from the method. This gets back to the common build, and common build behaves exactly like it does now. It got an error or not, depending on which state it was, it executes something else or not. When this is finished, we go to the cleanup method of the executor. And at this moment, executor knows if someone connected to the web terminal or not. We don't need to check it, it's checked already. And if it's connected, it just waits for the terminal to exit or for the timeout to kill the pod finally. If it's not connected, it kills the pod. So the only thing that is changed is detecting the exit of the script and detecting if it was failure or not.
Isn't it another change? Sorry, that the P1 bash script is gonna read the standard input and execute it as commands.
Well, if you attach to the container, then this is what happens by default. If you attach to the running container, you will be just thrown into the main process that is running.
Yeah, we need to change the script to read from the input and execute
it is already because this is a running shell.
Oh, okay, yeah.
This is a running shell. So when we attach to this process, we attach to the running shell. In this command, standard input is just the input of the shell. So everything that we'll write to this process is being write to this shell. What we need to do is we need to switch from exec to attach. We need to update the script, at least for the Kubernetes, so it will not exit, but we'll have there a trap that will catch this exit code and write something to the output. And after we attach, after we send the script to the standard input, we don't leave there attached looking on the standard output and standard error of the process, but instead we switch to logs, or we switch to logs in case of when we will be disconnected. However, switching from the beginning would probably make it less confusing in the code and just simpler. Like we will have one way to read what's happening in this job.
Is that kind of correct, Thomas?
Let's remove this. And here we would get the next have the something like that.
Okay, so maybe if we go through these two real quick, this one I think is going to be simpler. the first one, but it's not gonna solve the problem of long-running jobs dying. This one is gonna be a bit less simple, but it's gonna solve this problem.
I'm not sure about this, but we have an issue with our issue tracker regarding Kubernetes ignoring the entry point or something like that. Would kubeexec still have that problem? Would the entry point be considered, or am I just?
Well, the requirement that we have for runner from the beginning is that you need to have the shell. And in case of Docker, you need to make the container started with the shell in the front. So if we have any problems with entry point on the Kubernetes executor, it needs to be fixed, but this doesn't change the requirement. We give you the entry point so you can do anything that you want, but finally you need to give us the shell there, so we can start executing something on this shell.
Okay, makes sense.
I like the last point the most just because it solves all our problems. The other one seems a lot of complications, and it's still a workaround and a bandage.
Yeah, and I don't really like to use the file and kubectl exec cat file is. I just don't consider this to be the easier way.
Yeah, exactly. And we already have issues in the future where we want to save the build directory like we do on Docker. So we can do a git fetch instead of a git clone every time on Kubernetes. And if we save files, that's going to be even more of a problem.
This file would not need to be in the same place.
But
working directory. It could be on run or TMP, but
it's still a headache.
Looking on this, it looks just like a nasty hack to prepare a workaround. It doesn't look like a proper solution.
Yeah, I agree.
And the second version looks way more proper. I'm still not a big fan of using the output and some specific markers to detect the failures, but it's still better than in my meaning it's still better than saving the exit code to file and then reading the file to get the exit code. Like, we don't have exit code at all at this moment. We have some string that needs to be read. And in this case, reading the output is just simpler. It's one step less that we need to do.
Yep. So maybe we should go ahead with this, or do you want to, I don't know, reconvene in Wednesday and see if we still all agree that the last point is the ideal solution? And maybe, let's say, let's do a POC. Like tomorrow we do a POC and say, okay, Wednesday we sit down again and say, is the POC like extremely hard to do? Is it a terrible idea now that we're coding it, or what are your thoughts?
Mm-hmm. Yeah, let's just do a little pause and get back to this.
Okay.
I don't know, maybe let's get also Elliot, maybe let's ask Kamil if he can join. He could also have some different point of view on this issue. Maybe he will just give some idea that we didn't think about today.
Do you want to sit down tomorrow, Georgie, together and try and do the POC? Or you and Thomas or whatever?
Yeah, sure.
And we'll set up a meeting for Wednesday. afternoon, so Elliot can join us. Does that sound like a plan?
Yeah, sounds good to me.
Yep.
Awesome.